Hello everyone, welcome to MyJoy Vet Monitor Training today. I would like to introduce our new generation vet monitors, ePM Terran Vet. So the slogan we designed for ePM Terran Vet is intelligence for safety. I hope by the introduction for the next 1 hour, you will see why we designed the slogan for ePM Terran Vet, just like this. Here is the contents for the training today. The first part is smart and simplicity. Second part, excellent performance. The third part, reliable quality. The fourth part, differential positioning. So all the details we can see from the next slide is all for the ePM 12M vet. First, let's see about the smart and simplicity of ePM 12M vet. The first design we applied on ePM 12M vet is the high definition touchscreen. So for this touchscreen, resolution is 1280 multiplying 800 pixels. And by these resolutions, we can provide very clear visions about the waveform, measurement data, alarm message, and all the other details, including the time, battery, and also the parameter settings. And the second point about the high definition touchscreen we applied on ePM is the wide visual angle, more than 170 degrees. So why we apply such wide visual angles on ePM? Because as we know, during the surgery, the veterinarian will not stand beside the patient monitor. She needs to, or he or she needs to go to different positions to do the surgery. Sometimes near the patient monitor, sometimes far away, sometimes in front of the monitor, sometimes in the other sides. So the wide angle visual of the screen can make sure that the veterinary can see the screen from different positions and different angles. So this is quite helpful and useful. And the third part about the touchscreen is gesture controlled, just like the smartphone on your daily use. So you can use the gesture controlled to do the setting, to do the switch between a different screen, and also for different part of the operations. I'll introduce the details from the following slide. Okay, first let's see the two steps for normal operations by the touchscreen. So as we can see here, the ePM 12M vet is the first gesture control veterinary monitors on the world. So by this gesture controlled, if you want to do the normal interface switch, you can just use 2 fingers and to slide on the screen. Then you can switch, for example, from the picture here, switch from the big numeric screen to the normal display screen, just like we see here. Or you can use 2 fingers to slide out on the screen. Then you can do the discharge of the patients. It's very simple and very quick reactions, very easy to use, right? And for the long trans and mini trans switch, I'll introduce later when I introduced the mini trans and long trans. And also, if you want to do the menu slide, just like we can see from the screen here, you can just click the buttons here and then to slide it to the left. Then you can just hide the mini trans screen and then to see the normal screen. And if you want to do the screen setup or do the menu setup, you can just click the screen setup. Then the setup menu will pop up. And if you want to see more details, you can just place your finger on that and then to slide it up. Then you can change from the heart rate setup to the SpO2 setup. Then you can do the setup here according to your needed. So this is quite convenient and easy to do the controlled by the touchscreen and the gesture controls function of the ePM tail and that. Okay, next let's see some clinical assistive applications. First is the mini trans screen. On a mini trans screen, the first important function we can provide it by the mini trans screen is the routine vital of the preoperative normal signals. As you can see from the screen here, this is the routine vital of the preoperative normal signals. If you want to say those routine vital signals of the preoperative normal signals, you can click the routine vitals buttons. Then the system will just record or to display the time you press this button, and then to display the vitals parameter measurement result on the screen to tell you the reference during this time. And during the surgery, by the mini trans screen, you can see the changes of the parameter measurements. And if there's any abnormal happens during the surgery, you can the users or the doctors can decide how to perform the surgery, or if they need to do some other surgery or some put more medicines to the animals. And this function also very helpful for the statistics of the intraoperative abnormal alarms. So after the mini trans screen, let's see the long trans screen. So compared to the mini trans screen, long trans screen can present the complete condition changes of the animal during the surgery. If you want to switch from the mini trans screen to the long trans screen, you only need to use the finger to press the button as the picture show here, and then to slide to the right side. Then you can see the longer trans on the screens. And during the monitoring, the long trans screen will highlight the abnormal data. It's also very helpful for you to do the statistics of the important alarms, and also it was suitable for the long-term post-operative monitoring and case analysis. Of course, all those data you can export to the USB and then to do the rebuild by the CMS viewer after you copy it to the computers. So for the CMS viewer, I will introduce later. So next clinical assistive application is the tactical screen. By this tactical screen, First, you can see the target range dashboard of the key parameters displayed on the screen. So the dashboard will just tell you if the current measurement result is fall within the preset target range. The target range, of course, can be set by you, by the users. So this is the SBO2 monitoring, and then you can select it, change it to CO2 monitoring. Then also you can see the dashboard here, just like the dashboard on your car to tell you the speed of the car. And the target range can be set by the users. You can just click the dashboard area. Then you can have the pop-up menu to set up the different range. So those selections, those sections are the preset sections or the default sections designed by the monitors based on the clinical requirements from different hospitals. Of course, the range, the upper range, the upper limit of the range can be set by the users. So this is not this is quite convenient and also very useful for the user to focus, of the doctors to focus on the vital parameters measurements. Okay, then the next intelligent assistive applications provided by ePM and VET will be the smart lead off plus the visual alarm. As we know, the ECG lead fall off will be the main challenge in the during the ECG monitoring. So if there's any lead fall off, there will be no reading from the selected ECG leads, and then you will see no measurement result from the screen. By the smart lead off functions, you will turn on the smart lead off. The system will automatically switch to the available leads when the first ECG lead detached. Make sure the continuous monitoring. And combine with the visual alarm. When the ECG lead off happens, you can click the ECG lead off area. Then you can see this pop-up pictures just to tell you which lead has the ECG lead fall off. Then you can do the troubleshooting accordingly. You will save your time to help you to improve the troubleshooting efficiency. And we also can provide the customized configuration on the ePM Tel MVET, and by one click you can just load the customized configurations. We can provide up to 25 customized configuration, and you can set different alarm limits setting for different animals. For example, you can select, you can set the animals to canine or to feline, and then you can do the setting accordingly for the alarms. And we also have the default item setting for each interface and functions, and you can just set the do the settings based on the default settings. Of course, you can customize the name of the configurations. For example, you can set it to Dr. Paul or Dr. Paul's or Dr. Phillips, just like that. Then you will note which doctor normally use which configurations, and when you select the configurations, you can just click this configuration and then to load it. And also we can support the export and import by the USB key. So this is quite convenient if you want to make sure, or if you want to make all the patient monitor in your hospital to be the same, to have the same configurations, you can use the USB to transfer the configurations from one to one, which means if you finish setting, you can finish the setting on one monitor, and then to export the configurations to the USB, then to import to other monitor, and then load the customized configurations one by one. So this is quite convenient. And this is the steps show you how to do the configurations loaded. You can just click the load config shortcut key on the bottom of the screen, and then you can see the selections for different configurations. And after you select this one of the configuration, you can just click load, and then the system will just load the configurations automatically. So it's quite convenient. For ePM Tel MVAT, we also can provide the Excel format data compositions. It's quite convenient for case statistical research. As we can see from the pictures, you can find out the discharge patients menu, and then you can select the patients discharge patients you want to export to the USB key. And we can support, you can tell MVAT can support 101 historic patient data, 120 hours trends, 1,000 events and related waveforms, 1,000 groups NIBP measurement result, 48 hours full disclosure waveforms, and also we can support the data to USB key, as I mentioned. So after you select the discharge patients and export the patient data to the USB key, just like we can see from the picture. And then we can provide the CMS viewer for you to view all those data on your computers. You can plug in the USB disk. Then you can click the menu here. I mean, by the My icon. Sorry. Then you can see the menus pop up. Then you can select the browser. After you enter the browser menu, you can just select the browser, and then to select the patient's data from the USB key. After that, you can see the patient data display on the Sinapsis Viewer screen. Then you can select the patient data you want to view. Then you can enter this menu to see all the patient's information from that. Then you can just see the tubular trends, graphic trends, events, full disclosure waveform, arrhythmia, statistics, tail lead ECG, and also the ST analysis for all those things. And you also can export those data to USB key again, or to the local disk. Then you can convert the data to the Excel format. Then you don't need to use the Sinapsis Viewer to build those data, and you can do the analysis by yourself if you want. So this is quite convenient. And for the data export, actually, when we export from the ePM Tel M VET, is the CVS format or our own format. So we cannot build it by the Excel file, which means you need to use the Sinapsis Viewer to do the format, to convert the format to Excel format or CVS format. Okay, next let's go to the excellent performance introduction of the ePM Tel M VET. So first, ePM Tel M VET can provide comprehensive parameter monitoring. So as we can see from the list here, the except the basic 6 parameters, I mean for the ECG, SpO2, NIBP, respiration, and temperature, ePM Tel M VET also can provide the CO2 monitoring, including the side stream, micro stream, and main stream, and can support up to 4 IBP channels, which means, as we can see from the picture here, there are 2 IBP ports on the unit's main body, and then you can plug in one IBP module into the module rack here, and then you can have 4 IBP channels on the ePM Tel M VET, and also we can support the CO2, the CO monitoring, and also the multi-gas monitoring, including the O2 monitoring. And of course, for the SpO2, we can provide the Majoy, Nelco, and Massimo SpO2 on ePM Tel M VET. And as I introduced, we have the module rack on the ePM Tel M VET. So which means you can just open this door and then to raise up the module rack, and then you can plug in the module into the ePM Tel M VET. So it's plug in and played, very convenient and easy for upgrade. Then we have, as we can see from here, just like I introduced. So this is the IBP module I already introduced, and then we have the CO2 module here. Okay. And first, for the monitoring of the ECG, I will introduce some details. I mean, for several vitals parameter monitoring, I will do the introduce from the next few slides. First is the ECG. So this is the current station situation of the ECG measurements. So for the animal skin, adheres so it's not good, and electrodes easy to lose and fall off, signal interference. So this is the picture that showed the interference on the ECG monitoring. And when the ECG lead fall off, we also can see the flat line on the ECG waveforms area. So, which means all those problem will cause the heart rate calculation is not accurate and arrhythmia analysis errored. And on ePM tail MVAT, we are using the multi-lead analysis algorithms, just like we can see the process here. So we can have a two-channel original data. We send those measurement signals to the monitors, and the monitor will do the channel 1 and channel 2 heartbeat detect clarifications. And then we will do the lead optimizations and do the analysis. And then to provide the heart rate calculations, arrhythmia analysis, SD analysis, and the QT analysis. So, as you can see here, for single lead analysis, when there's interference happens, we can see the waveform on the screen is disorders, and also the cardiac rate is alarm will be triggered, and then the heart rate will be very high. But if you use the multi-lead analysis, you can see that the signal, I mean the measurement data of the ECG will be much better, and then the system will just filter the interference, and then to find out the accurate ECG heart rate. So this is the comparisons between the single lead analysis and multi-lead analysis. So we can see the advanced of the multi-lead analysis algorithms. So we have the patterns of Chinese patterns of these multi-lead analysis algorithms. Okay, next let's see how we improve the NIP measurement algorithms on ePM tail MVAT. And as we note, there are two factors affect the NIP measurement. The first factor is that the signal is too weak. Another one is the motions of the animals. So first, let's see why the cost for the weak signals. As we know, the blood vessel of 2 to 3 kilograms small animals had the small elasticity and weak blood pumping functions. Based on this factor, the pulse signal of the small animal would be very weak, cannot detected by the traditional NIPV measurement algorithms. So it causes the problem that the NIPV signal cannot be detected, not easy to detect it, and the blood pressure cannot be measured accurately. So we applied the weak signal detect algorithm on ePM tail MVAT. As we can see from the picture, the first step of the detection is to recognize the weak signals. So those signals, as we can see here, it cannot over the limit of the detect threshold of the pulse signal. So that's why the system cannot detect it. Then the second step, the algorithm will just amplify the weak signals to make sure those signals can over the detect threshold of the pulse signal. And then the system can detect the signal and do the measurement correctly. And the second factors affect the NIP measurement is the motions of the animals. So during the operation, the animals were in a state of shallow anesthesia, still has spontaneous breathing and prompt to body movements. And by the body movement, we will know that there will be the interference on the NIPP measurement result, as we can see from the picture, the omno signal. So then the problem caused by this issue is that the disturbance signal produced by the body movement is similar to the pulse signal, and which is disorderly and too much interference lead to the inaccurate blood pressure measurements. So we applied the anti-motion algorithm designed on NIPP measurements. As we can see, the measurement process for this algorithm is first recognize the interfere signal, as we can see on the picture here. Then the second step, you just correct and revert the interfered signal to the normal signal. Then the system can detect the NIPP measurements correctly and provide accurate NIPP measurements. And compared to Suntec, as we know, Suntec is the golden standards for the animal NIPP measurements. So we are used the NIPP measurement on our monitors to compare with the Suntec. So as we can see on the picture here, so 95.5% of the measurements, NIPP measurement by MyG monitors will be accurate, and then Suntec only has the 93% of the accurate measurement results. And on the picture here, the measurement results comparisons, we can see the measurement results statistic summarize or the waveform. MyG is quite similar or very close to Suntec. So which means after the optimizations, MyG and NIPP measurement algorithm will be better than Suntec. Next, let's see for the SpO2. So for animals, temperature under the surgery was low, and the calculation was poor, and then the pulse signal was weak. So it was difficult to detect the SpO2 signals during this time. So as we can see, this is the comparison between the low perfusion SpO2 waveform and the normal SpO2 waveform. For the low perfusion SpO2 waveform, the amplified, it will be much lower than the normal SpO2 waveform. So it will cause the problem that the SpO2 measurement is not accurate during this time. So in order to fight against that or to improve the measurements, we have applied the anti-lower perfusion technology on the SpO2 measurements. So according to the PI value, this is the perfusion index value, the infrared light intensity of the sensor is automatically adjusted to ensure the accurate signal collections. So which means when the pulse index is lower than certain level, normally is lower than 0.3, then the system will just adjust the lights to make the better measurements. So we can see the comparison between the without anti-low perfusion algorithm and with anti-low perfusion algorithms. So as we can see here, the the pulse index is 0.13. And if you already used, or if you have used the old versions Myri monitors, you will note when the pulse index value lower than 0.3, normally there will be no display of the SpO2 value on the screen. So which means on ePM tail MVAT, after we applied the anti-low perfusion technology, the SpO2 measurement will be much better than before. And then another problem for SpO2 measurement is the animal's movement during the surgeries. So you can see the interference for the SpO2 waveform if there's any movement by the animals. Compared to the normal SpO2 waveform, you can see the difference. So during the animal movements, normally the SpO2 reading will be not accurate, and then will trigger the long alarm or the false alarm. So we apply the anti-motion technology on Myri SpO2 technology measurements. So as we can see the picture here, when the pulse rate is or the waveform is not is disordered, or and then the system will just do the filter on the waveform, and then to adjust to the normal waveform, and then the system will detect the SpO2 normally, and then to display the accurate SpO2 result. Okay, next let's go to the CO2 and Hg monitoring part. So for CO2 and Hg modules, we are adopt the design or this technology from the Atima technology. So this is the golden standards for the gas detection in the field by human medicals. So they have a clinical research and technology accumulations in nearly 30 years. So I think for the human medical field, this is already widely accepted and to be proved. It's very accurate monitoring for those by the Atima technology. And as I explained before, the ePM tail MVAT can provide the module rack, so you can just plug the module into the units, and then to use it is plug in and plate. Of course, for the CO2, you can select to have the module, or you can select integrated with the unit's main body. And compared to our competitors, you can see the CO2 provided by our competitors are external, and it's very easy to fold up and then be broken. Our CO2 module and the AG module can plug in into the units, so it's not easy to fold up, and it's very safe. And the options configuration we can provide for the CO2 module is the CO2 and CO2 plus O2 monitoring. For AG module is AG or AG plus O2. Of course, for CO2 monitoring, we can provide the microstream and also the mainstream CO2 monitoring. And we can see the difference between them is the for the side stream, we need to have the water trap to sample the gas to the module to do the monitoring. And for microstream, they are also use the sampling light to sample the gas from the patient side to the monitor, to the module to do the measurements. And for the mainstream, you just place the sensor on the patient side to do the monitoring. That's why they need to have the adapter here to place the sensor on it to do the monitoring on patient side. So which means for mainstream CO2, the disadvantage is that the sensor will be easy to fault up if you use the mainstream CO2 module to do the monitoring, and the sensor of the mainstream is very expensive. So this is the disadvantage of the mainstream CO2 module. And then we also can have the cross fusions technology to provide the intelligent multi-parameter fusions. So we can combine the ECG, SpO2, and blood pressure together to display on one screen and do the analysis for all those parameters. And if there's any interference signal happens, it'll be easy to be identified, and the system will just do the auto adjustment to make sure the measurement accuracy to avoid the false data caused by the interference signal from the interfering the clinical judgment of the doctors, and reducing the false judgment and also the false alarms. So this functions is quite useful and very helpful for the doctors to do the judgments during the surgery. But you need to disable the cross fusion during the CPR and also the CBP and also the IABP, intra-aortic balloon pump. Okay. Then we can see the details from the next slide, few slides for the cross fusions. So as we can see here, for ECG and SpO2, when the ECG signal is normal, the fusion mechanism is not active. And when the SpO2 signal is poor and the ECG signal will be fused during the SpO2 analysis to identify the interference in the blood oxygen signals. And if the ECG signal is poor, the SpO2 signal will be fused and analyzed during the ECG analysis to eliminate the interference in the ECG signal. Okay, let's see the examples under the cross fusion functions. So as we can see from this slide, the SpO2 signal here is not so accurate, and then we have the interference here, and the pulse rate is too low. If you select the pulse rate source from the SpO2 signals, is lower than 20, but actually from the ECG measurement, we can see the heart rate is quite normal, and then there's no problem for the heart rate. Then the system will just switch to use the heart rate as the resource for the pulse rate, then to provide the accurate pulse rate value. So we can see the signal here between the ECG and the SpO2 signals. And this is the note here. Because the quality of the SPO signal is not good, the ECG signal is fused in the SPO2 signal analysis process to help identify interference to provide the accurate pulse rate value. So this is the one of the applications of the closed fusions. And then for the another applications of the cross fusions. So first, let's see the signal, the note here, because the ECG signal amplitude is too low. SPO2 signal will be fused during the ECG signal analysis process to help identify the interference. And as we can see from the picture here, yes, the waveform signal of the ECG is quite low, cannot reach the measurement threshold. But according to the SPO2 measurements, the SPO2 value is normal and the pulse rate is normal by the SPO2 measurements. So the closed fusion will use the pulse rate from the SPO2 measurements as the reference to correct the heart rate to the normal range. So this function can reduce the false alarm for the systole and provide accurate heart rate value. Okay, then that's all the introduction of the excellent performance of the ePM tail MVAT. Next, let's see the reliable quality of the ePM tail MVAT. First, let's see the ECG electrode clip for the ePM tail MVAT. So this is the traditional ECG electrode clip. The problem is that for those electrode clip, the track is very short and very smooth. So it will be easy to pierce the animal skin and easy to fall off. Then on the right side, you can see the the electrode clip provided by Mindray. So we have the group designed on the front of the clip. It's not easy to follow up and keep the signal collection stable. And then we have the large surface track design, increase the force area and avoid piercing animal skin. And also the clamping tools design ensure the stable connections of the clamping piece. So the position and the length of the clamping tools are suitable for the characteristic of the animal body to ensure comfortable of the animal. Then for the SPO2 clip sensor for animals, on the left side you can see the SPO2 sensor from other brands. So the problem is that the linear track strong force easy to piercing animal skin as the ECG electrode clip, and then but it will also be easy to follow up with a low force after a few times used. Then you can see the clip sensor provided by Mindray. So we can provide a different size of the clip according to the measurement site. And the round clamping surface and the non-slip design can maintain the proper clamping force while ensuring you will not fall off and improve the comfortable of the animals during the monitoring. And then we can see the Mindray solutions for the accessories for ECG, for the SPO2 sensor, and also for the NIBB cup. For ECG, I already introduced is the crocodile electrodes, and then for the SPO2 sensor, we can have the different SPO2 sensor apply for different place of the animals, just like the ears, tongue, lips, foot pads, furry skin, verbenna. And for the NIV curve, we can provide fine sizes of the NIV curve suitable for multi-size measurements of the different body types of the animals. And for the accessories, we also do very serious test in the factory during the manufacture. So the cable is designed to resistant to bending and has passed the high strength bending test. It's more than a 2,000 times cable bending test. And also, we use the high quality outer cover materials resistant to to different cleaning and disinfection agents, not easy to turn yellow and hot. So we have done more than 1,500 times wipe and cleaning and disinfection test, and can support 29 kinds of the cleaning and disinfection agents. So this is the list for the cleaning and disinfection agents we can support by our accessory. And also we can we have the high quality surface materials for the ePM tail and vat. So we can declare to be compatible to 49 kinds of the cleaning and disinfection agents. That cells is not easy to turn yellow and crack after long-term use. So this is the list for the cleaning and disinfection agent we can support. You also can find it for our user menu. So which means almost all the main brand of the cleaning and disinfection agents in the market can be supported by the ePM tail and vat. And in the bottoms, you can see the agents support by our competitors. Compared to this, that's nothing. And ePM tail and vat also has the fanless design. So by the fanless design, we can make sure there's no cross infections, protect the health of animals and the doctors. No internal dust, which means the dust cannot go into the machines from outside. Then this can make sure the reliable and stable system operations. Without fans also means there will be less noises. So the monitor can create a quiet and comfortable environment for the users. And also can avoid the animal's hair from sucking into the equipment. And also we can have the compared space layout and thermal balance design, as we can see from the pictures on the right side. This is the comparisons between the under the different temperature. We can see the temperature inside our monitors. So as you can see here, is there's not too much difference when the temperature changes from one to another one. So these are all the introductions of ePM tail and vat. Finally, we have the summarize of all the advanced or the sales point of the ePM tail and vat here. So this is all the things we would like you to remember. All those
things are already introduced. So first is the smart and simplicity for the ePM Tier 1 vet. So please remember, ePM Tier 1 vet can provide 12-inch capacitive touchscreen, support gesture controls, and has the flat UI user interface, two-step to finish the normal operations. And also we can provide different assistive applications functions for you to support you to do the judgments or help you to do the judgments during the surgery, during the monitoring. First is the tactical screen and the routine vital of the pre-operative normal signals in mini-trans. And then we have also have the visible alarms, the customized configuration, and one key export data on the ePM Tier 1 vets. Then for the second part is the excellent performance. First, we have the anti-weak signals and anti-motions NIBP and SPO2 algorithms. Then we have the unique patterns ECG monitoring, which is the multi-lead analysis of the ECG monitoring. Then we have the advanced monitoring from the CO2 and AG module. Finally, we have the cross fusions, which is the intelligent multi-parameters fusion technology to avoid the false alarms and then to make sure the accurate measurement of the pulse rate and heart rate. And the third part is the reliable quality. We have the dedicated accessory for the vets, and also the high quality outer cover materials for monitor and accessories. We can support up to 49 kinds of the disinfection and cleaning agents. And then finally, the last but not least, the fanless design to avoid sucking hair and dust into the equipment, to make sure that the equipment has the stable and long-term running times to save your cost. And then let's go to the differential positioning of the ePM Tier 1 vet. So this is the picture, shows the material monitoring family product positioning from Midray. So for the we divide the hospitals to different levels: large, middle, and small. For large hospital, we identify that will be more than 10 vets in the large hospital, and for the middle-sized hospital, there are 3 to 10 vets. For small hospital, will be 1 to 3 vets. So for the large hospital, we are using ePM Tier 1 vet to go to those hospital, including in China, RW, and also Europe and North America. Then for the middle size, and in China, we use the UMAC 12 vet plus a CO2 module to go against that. And for RW, Europe, and North America, we are using ePM Tier 1 vet to go for that. And for small hospital, in China, we are using UMAC 10 vets. In RW, we are using UMAC 12 vets. And also in Europe and North America, we are using in Europe we are using UMAC 12 vets. In North America, we are using ePM 10 vets to go for the small hospital. So the reasons we designed for such positioning is based on the situations in different regions and different countries, because the hospital, even for the same level hospital in different regions, maybe they have different requirements. And so that's why we have such kind of the positioning of the products for the monitors. Then this is the difference between the ePM and UMAC. So first is the structure. Even telling that, as I explained, we can have the liftable module rack. So which means we can have a flexible parameter expansions, just like Guy explains. You can just plug the module into the monitor and then to use it. But for UMAC 12W is the integrated, so which means if you want to have the one parameters on UMAC 12W, the better you can select it before you when you place the order. So this is quite important. And then for the screen, even 12W has the 12-inch capacitive touchscreen and can support gesture operations. And UMAC 12W has 12-inch screen, but touchscreen is the optional. And the screen resolutions, ePM is 1280 multiplying 800. UMAC is 800 multiplying 600. So this is the resolution difference. And as for the standard configuration, they are the same. Okay, sorry. For the ePM 12W, it has the 6 leads ECG, but UMAC 12 does not have it. And then for the option configurations, we can see there's more options on ePM. So ePM has the 12 leads ECG, Neoco Massimo SpO2, side stream, main stream, micro stream CO2 for channel IBP, CO measurements, AG plus O2 measurements. AG cannot use with the 4-channel IBP at the same time. That's because for the module rack on the ePM 12W, there's only 2 slots, and one AG module will occupy those 2 slots, which means you cannot plus the another 2-channel IBP module into the units. So that's why AG module cannot use with the 4-channel IBP at the same time. But for UMAC, the optional configuration only side stream CO2, 2-channel IBP, and CO, which means UMAC 12 cannot support mainstream, microstream, and AG module. So that's the difference. And then for the arrhythmia analysis, ePM can support up to 25 kinds of the arrhythmia analysis, but UMAC 12 only support 23. For the multi-parameter fusion algorithm, is only available on ePM 12 and VAT. For UMAC, does not support these functions. And for the interface selections, for the ePM, you can support normal screen, mini trend screen, long trend screen, target goal screen, and big numeric screen. For UMAC, only support normal screen, mini trend screen, big numeric screen. But please notice that for the mini trend screen on UMAC cannot support the routing vital of the preoperative normal signals. And alarms. The ePM can support the visible alarm and smart lead off. UMAC 12 only support the smart lead off. And for the customized configurations, ePM 10 VAT can support 25, and UMAC only support 3. The data export, we can see here. ePM 10 and VAT can support Excel format, but you need to use the CMS viewer to revert the format from MyG-on format to Excel format. And for the UMAC 12, only support the MyG-on format. And for the disinfection and cleaning agents, ePM can support up to supporting 9 kinds. UMAC only supports 7 kinds. So these are the comparison between the ePM and UMAC. So that's all for the ePM tail and VAT introductions. If you have any questions, you can ask later. Thank you.